Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
All right. Last session of the day for everyone, right? Except for the keynote. And then drinks afterwards, right? Excellent. So this is my talk, a knapsack of Geotools. I was trying to find a good name for it, but it's just a collection of a lot of things that I find interesting related to geo data and various geo things. So it's it. Some of you may have been in my ElasticSearch talk yesterday, but I'll just repeat this. I'm an architect at AppDynamics. You can ask me about what we do. We're going to have a pretty cool product coming out for PHP later this summer. I used to be a PHP core developer. I co-wrote Smarty, which some of you may use or abuse. I did PHP GTK project, Unicode, and a bunch of other stuff. I like coding, traveling, photography, beer, brewing, in whatever fashion or order. If you like any of that stuff and want to talk about it, we can do it when the drinks start. And I'm at A on Twitter. If you just reply to me, I might not see it until I finish the project, but actually cleans my reply stream up. So why this talk? Why do we need to talk about geotools and geography and all that stuff? Well, I went back to 1990 Dilbert cartoon that I love. Basically, I'll let you read that and what I'm trying to do with the talk is, basically so you understand why X doesn't move around or why it does. In our current world, location is more important than ever. It's become such an integral part, especially of mobile data and mobile technologies. I think from what Joe Stump was telling me, a report he read, next year there will be 1 billion mobile phones sold versus only 500 million of PCs and personal computers. So that's increasing the reach of location data and the necessity of understanding it. So you need to understand some basic geo-related principles. You can't just start talking about location like you know everything about it unless you have some background into it. So this is going to be like a survey of some tools, services, and technologies. And it's not an exhaustive reference, but hopefully you'll take some of this and go research things later in the directions that you find interesting. So some background. Let's talk about how our location is represented. And basically it's spherical coordinates since, let's say Earth is a sphere. And in our case, latitude and longitude is what we call the coordinates, and latitude is the angle between the equator plane and the normal that passes through the point you want to measure, so that's latitude. And longitude is an angle east to west from a reference meridian, which is the 0 one, east to west, to the meridian that passes through that point. Lines of equal latitude are called parallels. You've probably heard that before. 0 parallel is equator, and 23 degrees 26 minutes north and south are called tropics of Cancer and Capricorn. And lines of equal latitude are meridians, and by default, 0 is called prime meridian, and it passes near the Royal Observatory in Greenwich. It was I say arbitrary, but there was a big congress in 1884 that people got together and voted where the prime meridian was going to pass through, and they decided it would be near that location. Interestingly, Dominican Republic voted against it. Not sure why. There are also two things called antipodes of prime meridian, which are 180 degrees west or east, which are actually the same meridian, but depending on which way you measure, there are two of them. Now, latitude and longitude can be expressed either as degrees, minutes, and seconds, or in decimal degrees, depending on which literature you're reading or whether you're working with computer numbers or not. And you usually don't do this conversion manually, but for example, 37 degrees, 45 minutes, and 35 seconds is 37.76, and so on. And by convention, we call positive latitude, which is above the equator north, negative is south, and then positive longitudes east of that reference meridian east, and negative are west. And once you take that, longitude and latitude are enough to specify any location on the planet. And that's all cool, but it's a three-dimensional object, and latitude and longitude do not give you height and depth. There has to be a third coordinate for that. The other thing to remember is that Earth is not actually a sphere. It's what's called an oblate spheroid. It's slightly extended around the middle. So the radius at the equator and at the polar regions, it varies. At the polar regions, it's 6,357 kilometers, and at the equator, it's 6,378. So it's a significant difference, actually, especially when you start doing calculations. And 1 second of latitude which is going up and down, is equal to about 30.7 meters if you do distance calculations. But 1 second of longitude depends on which latitude you're at. Like at the equator, it's, let's say, 1 degree. 1 degree of the equator is 111 kilometers, but the more north you go, it starts decreasing. So like in Greenwich itself, at 51 degrees latitude, it's only 69 kilometers. And at St. Petersburg, at 60 degrees, it's 55. So you really have to take that into account with making any sort of calculations with related to distance or area and so on. So in computer representations, latitude and longitude can be any number of things depending on the software package you use. It could be just a string that puts them together, usually comma separated. It can be a list or an array of latitude, longitude, or the other way around. Or it could be some sort of object or associative array with lat long and so on. Historically, the ordering for those has been latitude first and longitude second. But the GeoJSON specification actually reverses that. It puts longitude first because in geometry, the x-axis is first and then y. And if you think about it, then longitude goes around the Earth this direction and latitude that way. And more and more software applications are switching to use this ordering. So just keep that in mind. Now, some gotchas about this is that there's that discontinuity at the international date line where the antipode of the prime meridian is. Latitudes, if you start going to the North Pole and then you wrap over it, it's all smoothly wraps. Like you go 0, 30, 60, you reach the pole, it's 90, and you start descending the other side, it's 80, 70, and so on. But longitude has discontinuity. You go if you start going east and you reach 180, all of a sudden it turns to the 180 degrees west or minus 180. And this really has to be taken into account if you do any sort of bounding box or other calculations. I've seen a number of errors, including I found a bug in ElasticSearch, for example, and a good thing the guy fixed it quickly, but it was just bizarre things pop up if you discount that discontinuity. So there's some math will appear on the screen, and this is sort of for your reference in case you start, you need to calculate distances based on latitude and longitude. It's a little more complicated than a normal Pythagorean theorem where you just take, square root of the sums of the squares of the triangle sides to figure out the hypotenuse. And you have to remember that in these, all angle measurements are in radians, not degrees, and conversion is pretty simple from degrees to radians, according to that formula. But there are three main things, or actually two if you want to talk about them. There's one called Haversine formula, and it basically calculates the great circle, or what's called orthodrome distance, and it's the shortest distance over the Earth's surface, like as the crow flies. If you have one point and another, just gives you direct distance between them. Basically what you see when airplanes, fly from point A to point B. It's not a straight line on the map because that's projection of the sphere, but it sort of curves like that. But that's the great circle distance. And it's pretty well conditioned for small distances down to several meters and so on. And this is the formula if you want to look at the slides later and play around with that. There's an easier formula called spherical law of cosines, and These days, we have 64-bit floating point numbers with 15 digits of precision. And these days, this formula actually gives very good results down to 1 meter. So if you want to use this simpler one, it works too. Before, 10, 20 years ago, the Habersign was more applicable because it gave better precision. However, if you need precision down to 0.5 millimeters for some reason, and also the other one's kind of a spherical Earth, this one does not. There's Vincenti formula, and I'm not listing it here, but you can go to the URL and look at the implementation. It's an iterative calculation. It goes until goes in a loop and performs the calculation until it reaches the tolerance that you need. 0.5 millimeters, sure. Another thing you may want to do is calculate midpoint between 2 points, and if you just average them together, or like coordinates, you'll get an approximation, which is okay if distance is less than 400 kilometers. But a better method to use is what's called the geographic midpoint method, and I have actually several slides with more math on it, but I'm going to skip over them just because of time reasons. I'll expand those for the online slides if you want to download and look at them later. But that gives you a very precise midpoint calculation. There are many other sort of coordinate systems that have been used and are still in use, something like Universal Transverse Mercator or World Geographic Reference System. They're less relevant for our purposes, but for example, GeoRef is actually used for airplane navigation, and what it does is subdivide the surface into a grid and numbers it, actually uses letters, starting from AA, AB, and going that way, and then it wraps around, starts BA, BB, and so on. And each of those gets subdivided further. It's like recursive subdivision. This is a newer way to represent coordinates. Anybody heard of GeoHash before? Okay. This is really cool. It was, I forget exactly who came up with it, but it's a very clever scheme where you can take latitude and longitude and encode them into just a list, into a string of numbers and letters, basically. It takes like binary representation of a floating point numbers for latitude and longitude, and then interleaves them, taking like 1 bit here, 1 bit from this one, second bit, and so on, puts them together, and then subdivides it into chunks, and each chunk will be a character, basically. And what it does, that way what you achieve is that at any point you can take a prefix of that geohash, and it'll still give you the center coordinate, but it'll vary the area that it represents. So it's a hierarchical data structure that basically subdivides the space into buckets. You shouldn't think of it as a bounding box, but more like a location with an error tolerance, where error tolerance can be in kilometers. I'm going to show you a little demo of that. So there's a visualization of this. I just typed in the address for Rai here, and I want a geohash of length of 5. So if we plot that, you can see that this is the grid with the buckets, and this is each of those has a specific geohash representation with the strings of letters and numbers. And let's say we wanted to have a little more precision, so we'd go to 6. So now you just zoom out a little bit. You'll see how that's inscribed inside the larger one. And you can go progressively down to meters and centimeters and so on, depending on what precision you need. Let's go back to this. Now, advantages of geohash is that, like I said, it's arbitrary precision, and it gives you gradual degradation where you can start cutting off letters and numbers from the end, and it'll just give you larger tolerance. And pretty efficient encoding. Instead of having 2 floating point numbers, you can basically have just a string of letters encoding that. And you can see how the tolerance here varies and how many bits you need depending on the length. So if you have geohash of length 8, then you're only about 19 meters error tolerance. But if you're at 3, then it's 78 kilometers. It's also pretty easy to share. You can just send that string to somebody, and it's pretty easy. You can convert it back to latitude, longitude. And it can be used for a simple version of clustering. I wrote a little in a project that I worked on. I used it for clustering. Basically, anything that had the same prefix, geohash prefix, I considered to be clustered around the same area, which has some problems because it can be hard to determine adjacency. Like the 2 points can be in 2 different cells, close to each other, but still have kind of different prefixes. So you can't quite rely on that. And it's not really good for distance calculations. And also, because it's a projection-based model, the same, like if you have, let's say, 6 character geohash, near the equator, it's going to have different region size that close to the polar regions because, it shrinks towards the poles. So just keeping that in mind. But otherwise, it's a pretty interesting model. We can also represent locations textually. Everybody does that all the time. Like points of interest. Hey, there's Eiffel Tower, or an address, just sending address around. That's a representation of location, zip code, neighborhood, city, and so on. Let's talk about geolocation methods. So traditionally, those old technologies, well, there were maps. And if you have a map and you sort of know where you are, you can be like, okay, so this is the only street that ends in a park, which is by the ocean, so it must be here. That's one way to do that. Or points of interest again. Okay, I see, Eiffel Tower. I pretty much know I'm in Paris. Or what sailors used to do is celestial navigation, which they still do. You need a couple of instruments for that and certain skills, but you can determine your location pretty accurately just from stars and if you have a good chronometer and so on. Some of the new tech that allows you to do geolocation, things like IP addresses. So there are companies who have databases of pretty much every IP range that's been given out and available, and they sort of know approximately where that IP address is, located. Well, IP address is in virtual space, but where it maps to in physical space. And we'll talk about that a little bit later. There's GPS satellites, which give you about down to 10 meters of accuracy. You basically, the way it works is you have 3, 4, 5 satellites which continuously transmit a timed signal. And if you're able to pick up that signal, you can do a calculation depending on the delay between those signals and determine your location pretty accurately that way. And these days, there's not just the GPS. GPS is basically managed by U.S. military, but there's a new one called GLONASS, and it's the only alternative navigational system with global coverage. This just came online recently, and it's Russian. So I don't know if anybody is using it, like what the reach of that is as far as consumer implementation and so on, but at least we have a backup if the first one fails, right? There's cell towers, which can be used to varying success. I mean, it can be from 200 meters to 20, 30 kilometer accuracy, depending on if you're in a rural area or if the towers are clustered closer together, you get better accuracy. Wi-Fi base stations is another one. It's once again, it's a database of well-known base stations. It's about 100-meter accuracy. And the other one I thought about recently was like, wouldn't it be cool if you have well-known servers around the world, like locations, and determine your location by ping times, sort of like GPS, but using ping times instead of time signal? And turns out somebody implemented that. That project called Tulip, and I tried it out. It's actually kind of not very accurate, but interesting idea. So GPS devices, they're pretty accurate, but it takes a little bit to acquire the signal, especially if you're in an area where the signal can bounce off buildings, for example, in the cities and so on. Or some of the poor signal conditions, cloud cover, any kinds of things. And the standalone or autonomous GPS operation basically just uses radio signals from satellites. So if you have one of those GPS devices that can connect to all 14 or whatever 15 satellites. It'll be very accurate, but it's going to be slower just to acquire them one by one. Then there's technology called assisted GPS or AGPS, and that's what iPhone, Android, and any mobile device basically uses. Because it first uses its network connection to contact what's called an assistance server, and it asks AGPS info from it, which is basically orbital data or almanac of the GPS satellites, and it also combines it with Wi-Fi positioning system and cell site triangulation. Then it hybridizes it together into one location system. Browser-based geolocation, sort of similar to that. There's an API that uses what are called location information servers. And the types of location information that those servers provide, or that not provide, but they can take in and give you back a location are things like IP address, Wi-Fi or Bluetooth MAC addresses, GPS or cell tower IDs, especially for mobile devices. And it's pretty well supported by modern browsers. I remember when it started appearing, it was wildly inaccurate, but these days it's actually pretty good. And it's not that hard to use. Here's a quick JavaScript template for how to do geolocation. You just say if navigator geolocation, then you have access to that, and then you basically do a call to get current position with the success and error callbacks. And there can be various types of errors, like timeout, you couldn't reach it at all, or position unavailable, and things like that. GeoIP. So I've mentioned the IP addresses a couple of times, and this is actually one of the more accessible ways to do geolocation via the browser or sort of API data or API calls, I mean. Has anybody ever gone to FedEx site and it asks you where you're from? And you have to find a country and click it? This is fucking annoying. Every time, and they don't even remember it. Same thing with UPS, and it's worse because it's a drop-down list. It's just terrible. It took me, I don't know, a couple hours. I was doing a project for our company's website where we use geolocation to, do some customized greetings for people where they're from and so on. It took me a couple hours to do initial implementation with testing and everything, and then be a day to really enhance it to have some cool stuff there. But oh man, and they have huge IT departments probably. So there are companies that compile this IP information, and the most comprehensive one is from a company called MaxMind. Probably, I don't know, you may have seen them mentioned. And they have two products, free and paid. And the free one is called GeoLight City. It has pretty decent coverage, less accurate than the paid one, obviously, and it's updated monthly. And the GeoIP City is the paid one. It's about $370 for initial license, and then you pay $90 a month. But you get weekly updates, if that's important to you, more coverage and better accuracy. Now, the coverage for the free one, and that's all I have experience for because I haven't paid for it, is about 99.5% on a country level. And if you want city level, basically which city can you locate me to based on my IP address, it's about 79% for the US within a 25-mile radius. They publish a table where they list this coverage for various countries. I just found it interesting that for the United States, it's 78, 79% of correct. Canada is about 81, but Kazakhstan is 84. And I don't know if it's because there are fewer cities there, so it's more accurate to locate that way, or Borat had something to do with that, or what? So MaxMind is just a binary database of that information. They also publish a C library called GeoIP, and this library is used basically by a bunch of various languages or client libraries, wrapped in client libraries to do the actual interface to that. So for PHP, there's a package called GeoIP, which is actually written by MaxMind, and there's a newer one that has better actually way better interface and I think functionality. Same for Python. There's a MaxMind that's older, and then the PyGeoIP that's newer, and other languages have their own. But I was so when I was working on that project for the company's website, I had to test a whole number of IPs to determine what greeting to show and so on. So it's one of the calls you can do in the library is GeoIP record by name, and you give it the IP address and it gives you back this array of information. So some of the information it gives you back is things like continent, North America, country code expanded, like 3-letter country code, country name, region is for US is a state, city, then latitude, longitude, which is important. DMA code, some sort of DMA marketing association, only applies in North America. And then the area code, like for your telephone, if it knows that, which is pretty cool. But then I put in my friend's IP address who lives in UK. I'm like, okay, I want to see what I get for that. And I was very surprised to find out he lives in London, which is nowhere near Barnstaple. And it's like 200 kilometers from Barnstaple is where he lives. So that was disappointing, but you kind of get the same information, region H9, latitude, longitude, no area code for UK, I guess. Also, I like that they give you 12 decimal digits of precision when it's completely wrong. And this is a perfect illustration of precision versus accuracy for you. Okay, you can be precise as hell, but if your accuracy is off, it all sucks, yeah. This is what MaxMind has. You just give it an IP and it's supposed to give you back location, right? Right. So here's another example of blindly using data. I put in a Korean address and it came back with Korea, Republic of. So you can imagine if you just took the country name and said, hello, you are from Korea, Republic of. So you had to massage the data, basically, or have an exception list or something like that. You can't just blindly take it and use it. And then there were a number of addresses where all I got back was USA, and that's it. And like no other information, no city, nothing. And they all had the same latitude and longitude. And for the longest time, I was like, what the hell is going on? Until I finally put it on the map. And I figured out it's the middle of United States, basically. Any IP they don't know where it is in US, they just put in Kansas. So Kansas is Middle Earth, apparently. It's like if you took a map, folded and twice, and it's right in the middle. There's another database called IP2Location, which is commercial. And then there's one crowdsourced one that hostip.info has. So I decided to test them as well. I put in my friend's address, and it came back with Sheffield, which is nowhere near Barnstaple again. Same address in hostip info, just says United Kingdom, which is sort of accurate, I guess. And this says, I don't know what city it's in, right? At least the other ones were certain they knew where it was in, but were wrong. All right. There's a very cool PHP library called Geocoder PHP that has a unified interface for a variety of IP-based geocoding providers. So if you want to switch between them, you just configure it with that provider and go on. So lessons from this is you have to expect failures from GeoIP and either work around them or word around them if you want to reword your stuff you're working on. And also another thing I haven't mentioned, but don't assume that the remote address, the remote IP you get back from the server is the correct one, because it may be coming through a number of proxies. The more correct way of doing it is to look at the x_4 header, because each proxy is supposed to append its address to the actual original one. So you have to look at the beginning or at the end to see where the actual client address is. All right, geocoding. So geocoding is conversion of address into latitude, longitude, and reverse geocoding is doing the reverse, latitude and longitude into address. It's not always reversible. So if you take, for example, Farallon Islands is a group of little islands near San Francisco where white sharks come to feed on dolphins or something like that. And you can take that, and it will give you latitude and longitude for that. But if you put latitude and longitude into reverse geocoder, it's not going to say it's Farallon Islands. It's just going to say nothing. There's some disparity of results too, so depending on the country. So for example, here, this is in, okay, so it gives you back like these hierarchical breakdown of administrative areas and so on. And for example, in the US, administrative area level 2 is San Francisco, but it also has locality San Francisco. And I was trying this for Montreal, and this says city, like community city with Montreal, and this is locality Montreal. So you really have to kind of figure out what country has what administrative areas and work based off of that. There are various libraries that help you do geocoding. For JavaScript, you have Google, Bing, MapQuest APIs, so just feel free to use those depending on the licensing terms and all that stuff. PHP has the geocoder PHP library again. It's very cool. It does reverse and forward geocoding. Python has GeoPy. Ruby guys decided to write, we want to do an open source geocoder, so they started from scratch and wrote their own. I don't know how well it works or anything, but you're welcome to check it out. Definitely check terms of service before launching publicly, especially Google is being more egregious lately with the restrictions and how many queries you can do daily and all that stuff. Or write your own, I don't know. Another cool thing you can do is location extraction, because you don't always get location in a structured format, like here's the address, or here's the city, or latitude, longitude. Sometimes you just get a text that may contain location mentions of some sort. Blog posts, articles, news clippings, they may contain locations. And the goal here is to extract these with as much precision as possible, and so you can do something on geocode or otherwise. And as far as I know, this is the only service that does it. It's called Yahoo Placemaker. There's an API for that. You give it a blob of text, and it basically looks through it and tries to determine what are the location names. It disambiguates them and gives you a unique ID back with them, what's called a Where on Earth ID, WOE ID. And the reason it disambiguates them is because locations may have names like New York, New York City, NYC, Big Apple, can refer to the same thing. It's all variant names. And what you get back is this Where on Earth ID, where it uniquely identifies it. And then you can take that Where on Earth ID. It also gives you back latitude and longitude, of course. But you take this ID and you can use it with Yahoo GeoPlanet, which has geocoding and other stuff. And so I encourage you to take a look at it. It's pretty cool, because you can basically highlight locations in the text, do whatever stuff you want with it. So storing and searching, some overview of that. I'll mention things that I've done or worked with. So if I don't mention your favorite one, sorry. So MongoDB has 2D geospatial indexes, supports that. And the location is basically an array or an object of at least 2 elements. And it interprets them as longitude and latitude based on GeoJSON ordering. And it's implemented actually via those geohashes we talked about that are on top of the regular database B trees. It supports multiple locations per document in case you wanted to store location history or something like that. And it's pretty easy to use. Basically, you say, okay, I'm going to have, how many of you are familiar with Mongo, like syntax or something like that? Okay, a few. Oh, right, so db.places is my collection, basically a table. And I say, I want to ensure that this, I want to create an index on loc field, location field, which is going to be 2D type of index. And then when you save your document, you give it the longitude and latitude. And that's it. And you can start querying. You can say db places find, and then want to query the log field, and this is basically Mongo syntax, but you say near this point and max distance of 5. And it doesn't say what 5 is, because by default it uses Euclidean geometry, just like plane, right? If you want to use sphere, which is actually what you want, because it's you're mostly working with spherical stuff, you have to use a different command. But anyway, or you can run a command called geonear places, sort of almost the same syntax, near, how many results you want back. The command will give you back the distance from the point as well. The first one won't, which is one of my gripes with Mongo. So if you want to use that spherical model, which is probably what you want to do. So you have your Earth radius. You have let's say I want to find it within 30 kilometers. You have to convert them to radians, so divide by Earth radius. And then you do location, near sphere, the point, and the max distance here. Run this command, get the results back, and then you basically, for each result, you have to take this distance, multiply by Earth radius, and you get kilometers back. So it supports bounded queries, so looking for points inside circle, bounding box, or polygon. And if you use bounding box, you have to remember that it's bottom left, top right corners, rather than everybody else who does top left, bottom right. So limitations of Mongo support is that you can only have one geospatial index per collection, which can be limiting, but you can usually work around that. Some query limitations with multi-location documents, and this inconsistent query syntax just really pisses me off. It's kind of awkward and inconsistent at the same time. And the other big one that people have been complaining about is that sharding on geo keys doesn't work yet. So if that, they suggest sharding on some other key like a document ID and using the Mongo S, which is the thing that sits in front of your shards and basically dispatches queries and collects the result back, using it that way. MySQL support is based on the OpenGIS model, and it's a lot more like abstract and academic. And it supports points, lines, polygons, so like actual shapes, and it's implemented using R3 technology, which you can look up if you want to. But let's say we wanted to create a table with geometric data. So you can say this field is going to be of type geometry, and we want to have a spatial index on it. And then if you want to insert data, you say insert into geom values, and then OpenGIS has this whole number of functions basically that for working with data. So apparently you can't just say insert, latitude and longitude. You have to say, you have to have a string that represents location or whatever, 0.11, and he'll call a function geom from text, and that actually will insert into the geometry. But my SQL guys, I guess, were smarter than that, and they said, okay, we're just going to add our own version of that where you can actually insert a 0.11 in there, which is much better. And querying, you do things like you do select MBR contains, so bounded rectangle, which is another OpenGIS function, basically. Geom from text, give it the polygon, so like you have to specify all the coordinates, and you basically get your points back or documents for those points. Only my ISAM table supports spatial indices. So if you want to use InnoDB, you can still do searches, they'll just be slower apparently. And also the Sphinx search engine, if you've heard or played around with that, supports geodistance search as well if you use it on MySQL. If you were here for ElasticSearch talk yesterday, I mentioned geo stuff briefly. It's just an illustration of how that works in ElasticSearch. You can have a mapping type of geopoint for your documents, for the fields in your document. And it's implemented via geo-hashes again. Surprise. And you can use either a string representing location or an array or an object or actually geo-hash. Give it to that too. It'll take anything and index that. And it uses GeoJSON ordering as well. So mapping specification, you just say, well, this is my type of my document. I have a location field, and it's a type of geopoint. It's pretty easy. It starts treating it as a geopoint on indexing and querying. Inserting, like I said, pretty simple. You just give it a put command with the document. In this case, I just have one field location with longitude, latitude, or you can give it more explicit one where you can actually name the properties and so on. Well, the same thing. And then you can query it by distance, so within a certain radius, bounding box, polygon. It doesn't support that rich OpenGIS models of lines and shapes, but that's fine. I think for most purposes it'll do just great. And in this case, bounding box is specified normally at top left, bottom right. So I was actually working with Mongo and ElasticSearch at the same time, and it was just drove me nuts trying to reconcile them together. So here's an example with search. I do a filtered query because the geo lookup is done by filters. So in this case, my query is match all. So I want all documents where the filter is geo distance, and I give it kilometers, how many kilometers from the distance it is, and the location that I'm interested in. What I found is that geo support plus text, like textual queries, is really awesome. It gives you a lot of power for your applications because you can do things like, I want to find all businesses that do, I don't know, pizza delivery or whatever else in a description and maybe in the name within 5 miles from my location. I want to segment it by how many are within 1 mile, 2 miles, and 5 miles, and then show the closest or float it, sort it, whatever. It's really cool. I encourage you to take a look at that. Postgres supposedly has the best geo support of any open source database via this thing called PostGIS, special extension of Postgres, but I just didn't have time to really go into that and learn all that. It also follows OpenGIS standard, and it's supposed to be a really good backend spatial database in case you want to do your own like map server or some other stuff. Okay, so a little more. Let's talk about if you're interested in actual data sets for working with some of this data. I'll just mention like a few of them. There's one called FreeGIS Data, and that's actually a big collection of various GIS data sets, including physical geography, so countries and various locations, or human geography, to like really esoteric things like places where wars have taken place, and a number of other things. The guy just maintains all that. If you're interested in neighborhood boundaries, and this may not apply here so much, but in US, this company called Zillow, who are doing real estate stuff, they maintain that data set. They actually have an API for figuring out which neighborhood you're in. Because real estate agents are really good about that, right? Like distinguishing, okay, you're like 1 meter there. Oh, you're actually in this neighborhood now. If you're interested in street data for US, actually US government maintains this data set called Tiger with street information, or OpenStreetMap project actually has really good street data. Some other ones, Flickr shapefiles. Have you heard about those? So Flickr basically, because I have so much data from photos with geolocation embedded, they decided to see if they could actually figure out region boundaries based on the photos. Like, so if you take all photos that say they were in Norway, for example, and you like take geocoordinates and plot them all as like a blob on the map, how accurate the boundaries would be, and it's actually amazingly accurate, like to represent the country. So they release those shape files as a data set. And then Yahoo GeoPlanet data also has a number of data sets for countries and cities and neighborhoods and so on. Some of the API services, I used to use simple geo services. Unfortunately, they went away, got bought by Urban Airship, and I think they actually stopped all their services. You can ask Joe more about that, who's going to be giving the keynote. He was the co-founder of Simple Geo. WebMap Studio is a suite of tools that gives you ability to basically create customized interactive apps based on maps. I played around with just a little bit, and it's really cool. I encourage you to take a look at that. GeoAPI is a company that I think got bought by Twitter, and it also did a lot of like points of interest information and geodata. Twitter still gives you the ability to access that. If you're interested in points of interest for like businesses and things and other things, Google Places, you can use their API. Foursquare is another one. Then there's a company called Factual that puts them all together, I think. Basically gives you a wrapping around the other ones. Some of the other things, EarthTools has a number of interesting web services, for example, for finding out time zone or local time based on location, or sunrise, sunset times if you need that. Also, elevation or height above the sea level. So because if that's important to you, you only have the location, but you want to figure out how far above the sea level that point is, if it's like a mountain or something. EarthTools can give you that. GeoNames has postal codes, geocoding, some place hierarchies. So if you start from street level and going up to countries, it can tell you that okay, this city actually has neighbors to the north of to the north its neighbors these regions, to the south these regions, and so on, basically around it. InfoChimps is another company that has a whole bunch of data. They actually also give you an API for like wrapping other services like Foursquare venues, Zillow neighborhoods, georegions, points of interest, and so on. And then just quickly running through this, if you're actually interested in mapping and representing this data on the map, there's a whole number of tools. And I'm not actually mentioning Google Maps here because my talk says more than Google Maps, but you're welcome to use that too if you want. Mapbox allows you to publish custom maps. CartoDB is more for representing or visualizing data sets on the map, if you're interested in that. Mapnik is a free toolkit for developing mapping applications, open source. And Leaflet is a sort of lightweight open source JavaScript library for interactive maps, especially it's mobile friendly. It's pretty cool. And if you're interested in route planning or doing any sort of routing, then there's a thing called Graph Server, which runs on top of GIS, Postgres, and basically write your own Google Maps if you want to with all this stuff. That's the end of my talk. If you have any questions, I can probably take some now a little bit, or come talk to me later. I'll put the slides up at that URL, joinedin/6285. Please rate the talk there as well. It's only the second time I've given it, so it would be nice to know what to change or to omit or to add. Any questions? Okay, thank you. Oh. Precision on what level? What on? Yeah, that's it really depends on the country and on the company. Obviously, in, for example, the United States, there's a whole lot of more, I guess, money dedicated to that versus, a place like, I said, Kazakhstan, right? But I mean, I don't have any data on how precise it would be, country by country. That'd be an interesting project to see that. Sorry. Oh, you mean like I want like street level versus city level and so on? No, there is. The Yahoo GeoPlanet has that. If you like the tolerance you want, like I want really. Like if you do reverse geolocation, or if you want to, like I want street level information versus I'm just interested in the city where that maps to. Yeah, that's the same thing. Okay. Oh, thanks a lot. Enjoy the keynote and the rest of it.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.